So very welcome, sir. Dr. Rahul, sir. Very welcome to the session.
Thank you, sir. Thank you very much.
Okay. So let me introduce Dr. Rahul Madhukar to all of you. So Dr. Rahul Madhukar is currently working as assistant professor at SB Jain Institute of Technology Management and Research, Nagpur. And sir has completed his BTech in Electronics and Telecommunication Engineering in 2003 and MTech in 2012 from RTM Nagpur University, Nagpur. Sir has completed his PhD in Wireless Sensor Network in 2020 from Nagpur University. Sir has more than 20 years of teaching experience and more than 50 plus research papers published in different national and international journals. Sir has total 10 patents published, and one of them is cooling and heating water by using thermoelectric module. Sir has 6 national and 2 international awards in his name. One of them is Dr. APJ Abdul Kalam Award for Innovative Research by Society of Engineering Education. And Sir has published 3 books. And Sir is also assigned as internal supervisor for RTM menu examination, LEC member, co-chair session for national and international conference. Sir is also active at national and state level. Sir is also active member of different organizations like IEEE, ISTE, SEE, SAS. So, and the list of achievement is going on. So we can say that Sir is master of his field and we can learn lots of things from the Sir. So all hands on to you, sir, and we can start the session. Thank you, sir. Hello.
Yes, hello. Can you hear me, audience?
Yes, sir. Yes, sir. I think they can.
Yeah,
We
right,
can
right,
start.
right. Thank you very
Yes,
much
sir.
for
Yes, sir.
yeah, right. Thank you very much for your introduction. Means that this introduction is not that much a part of my achievement. It's a because of some sort of achievement by all my students, all my colleagues, those who are a part of this particular activity, because all the patents has been done with respect to, or with the help of, I can say, my colleague or students. Even though about the papers and publications, again, as I am the PhD supervisor, so again the scholar, those who are associated with me, are being a part of this particular paper, so all credit goes to them. And even such type of people, those like you all, those who are being a part of such activity where I can be explore my skill, or I can explore my whatever the achievement with you all guys. So with this small note, I thankful to all the participants, those who are being a part of this activity. I will share my screen. Kindly just allow me. Hello.
Yes, sir. You can share your screen, sir. You can.
Yeah. So just give me a second. I will share my screen. Is it visible? It's accepted?
Not yet, sir.
Yeah, just give me a second. Okay. Is it visible? Hello.
No, sir.
Ankur sir?
No, sir. No.
नहीं सर विजिबल नहीं है
Okay, let me check. Just let me sort out the technical stuff. Just give me.
सर यदि आपके लेवल पे ग्लिच आ रही है तो आप एक बार मुझे भेज दीजिए, हम अपने मॉडरेटर जी से आपका शेयर करवा देंगे, रोहित जी से। राहुल सर, मेरी आवाज आ रही है आपको? रोहित जी, पेटे सर ने ज्वाइन कर लिया, आप उनको पोस्ट बनाइए।
Okay, sir. Hello, PT sir.
यस
Hello,
यस
sir.
यस, अभी शेयर कर
हाँ
सकता
डॉक्टर
हूँ
साहब, मेरी आवाज आ रही है आपको?
हाँ हाँ,
हाँ शेयर करिए प्लीज, स्क्रीन शेयर करिए आप।
यस यस यस।
जी।
इज इट अवेलेबल?
नहीं सर, यदि अभी भी कोई प्रॉब्लम है तो आप प्लीज मुझे पीपीटी शेयर कर दीजिए, रोहित जी उसको शेयर कर दें।
Done, sir. Done,
हाँ
sir. It is.
अब दिख रहा है सर, मोबाइल से कर रहे हैं ना आप?
हाँ 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 हाँ,
हाँ
It's
आप दिख रहा है सर, आप स्लाइड आगे बढ़ाइए।
nice. Slide.
सर रोहित सर आपका मेल आईडी बोल दीजिए।
रोहित जी आप चैट बॉक्स में चाहें या सर को ईमेल अपनी लिख दीजिए।
मैं चैट बॉक्स में सेंड कर देता हूँ सर आपको।
हम्म।
सर शेयर किया सर आपको?
ओके सर।
रिसीव हुई आपको?
नहीं सर।
भेजा है सर ने।
सर नहीं आया। आप एक काम करें, कुछ सर के साथ शेयर कर दीजिए, मुझे व्हाट्सएप कर देंगे सर, या ईमेल।
डॉक्टर साहब आप मुझे व्हाट्सअप करिए, अगर आप मुझे
आप
व्हाट्सअप कर
हम
देंगे तो हम व्हाट्सअप पे ही शेयर कर देंगे उनको।
हाँ सर, आप व्हाट्सएप पे मुझे डायरेक्टली शेयर कर दीजिए, मैं उसको चेक करूँगा।
मैंने व्हाट्सअप किया है उनको, क्या प्रॉब्लम आ रही है। पार्टिसिपेंट से रिक्वेस्ट है कि थोड़ा सा धैर्य बनाए रखिएगा। कभी कभी इस स्तर पर ऐसी ग्लिचेस, हम जल्दी इसको रिजोल्व करके सेशन स्टार्ट करेंगे। मैं पुनः क्षमा मांग रहा हूं कि कभी कभी ग्लिचेस ऐसी हो जाती हैं, हम थोड़ा सा अभी इसको रिजोल्व करके स्टार्ट करें। सर मेरी आवाज आ रही है?
Yes, sir. Clear है.
हेलो
नहीं इनको,
हेलो
हाँ हाँ
शायद आ रहा है.
हाँ डॉक्टर साहब,
कैन यू हियर मी?
हाँ
Yes, sir.
मेरी आवाज आपको आ रही है? डॉक्टर पेठे साहब, मेरी आवाज आपको सुनाई दे रही है?
हेलो हेलो
हाँ जी सर, हाँ जी सर,
कैन यू हियर मी?
हाँ आवाज आ रही है आपकी। आप मुझे सुन पा रहे हैं कि नहीं?
हाँ, बट ये म्यूजिक की आवाज ज्यादा आ रही है।
म्यूजिक की आवाज सर मेरी तरफ से कहीं नहीं खुला है। हाँ आप प्लीज स्टार्ट करिए।
मैंने स्टार्ट कर दिया है।
आपने स्टार्ट कर दिया है?
हाँ, शेयर हो रहा है मेरा स्क्रीन?
पीपीटी नहीं दिख रही? नहीं नहीं, पीपीटी आपकी विजिबल नहीं है। रोहित जी आपको दिख रही है क्या?
नहीं sir.
अरे यार, एक मिनट।
सर आप प्लीज मुझे व्हाट्सअप करिए, मैं इनके माध्यम से उसको शेयर करवाता हूँ, आप मुझे व्हाट्सअप करिए।
हाँ, अभी शेयर हो रही है, देखिए।
एक सेकंड एक सेकंड एक सेकंड।
Yes, sir.
हाँ सर
Clear.
अब हो रही है।
Yeah. So sorry for inconvenience. It is a technical stuff and technical error, as we know very well that we are very much good in technical, but somehow sometimes it is happened. So sorry, all my participants, all dears, hope you can understand. And as I see here, the number of participants are very good. And this is Rahul Pete from Nagpur, Rashtrasant Technology Maharaj, Nagpur, Nagpur. Can you hear me properly?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, right. So this is technology and the device which I can design. So if I need to design some sort of IoT, I need the devices like I can say that embedded system, nature, physics, machine, AI, electrical, electronics, arts, and mathematics. So these are the complete package where I can design a IoT device, IoT network. And as I see here, evaluation of IoT, evaluation of network, evaluation of sensors are from 1960 to 2014 onwards is very technological cyclically developed technology. As I'm talking about that IoT is a part of anything, anyone, anytime, anywhere can access. It can be a human to human, human to computer is a part of IoT. So this is some sort of object or a device which we can design, and that can be used for different applications. I can say that a big data, where I can have a social media, I have a mobile, I have a storage, I have a content, I have a risk. So this is a big data as far as the agriculture is concerned, as far as the other applications are concerned. So just if we'll consider example of any toll road, I can say that camera, I can say that speed camera data, car computing data, phone record, photos, videos, audios, and the numerous applications in a day, per day. I think you may also read these particular examples. We have a gadget as a mobile, as an IoT device, which have a complete data on a cloud. This is a platform Zoom where we are going to discuss a particular presentation from different area through a cloud itself. So see here, I have a ATM transaction. I have a camera uses in the ATM on the line transaction, camera center transactions, online purchase or payment gateway, website, internet marketing. These are the things which are most important factor for that particularly we can say that IoT. So how does big data evolve in and you are become engaged? So interaction and data through email, through clip stream, enterprise content, attributes, characteristics, self-declare. As we know that AR, VR is one of the booming technology, augmented reality and virtual reality. Attitude data, as we have an opinion, we have to like on Facebook, we have to create a comments on a Facebook, your preference as per your requirement on Facebook, Instagram, YouTube, whatever the things which is different. As we know that about our needs, as we know we are going to purchase something through Amazon. So this is a need, and if that need will interface with the different cloud audience, we are very much aware that if we'll search something on like Amazon, that will get interface with Facebook. Am I right? And that particular information is available on Facebook. For example, I'm going to search I can say that shoes on a Facebook, that will get available on a cloud of Amazon, that will get available on a different cloud of different social media. So these are the engagement in with respect to big data. Behavioral data, as we say that a payment gateway, Google payment gateway, Paytm, credit card, UPI. These are the contents which are most important factor for the big data. Hope you may aware about this one, and you may be a part of this particularly data, big data process itself in a daily to daily life system. As we see here, the digital data expansion from 2005 to 2015 onwards is zettabytes of data we are going to use, we are going to implement, we are going to access per day. And this is a part, as we know that about that decimal, nowadays we require yottabyte of data, okay, by a user per day nearby, because as we know that we use Facebook, we use Instagram, we use Gmail, we use Google, we use surfing. We have different app, we have different applications, and that all data are available on cloud. That clouds will access anytime, anywhere. We have a banking purpose, we have a banking applications, different banking application. As I have a different banking account, for example, I have a banking account in SBI, Union Bank, and other bank itself. So I have different login app, and through that login app I have to access my account detail. So that is a particularly, we can say that we have a internet of things addicted people, those who access per day yottabyte of data, I can say that zettabyte of data, or exabyte of data, or pentabyte of data. So kilobyte is not sufficient for a day, megabyte is also not sufficient for a day, gigabyte is also not sufficient for a day. What else, what exactly we require? So this is the big concept, big idea behind this, where I have to access a data. I can say here a big data. You can see here a big data, the two, people to people, people to machine, machine to people. So 2.9 millions, okay, like people, we access the data. 20 hours of a video uploaded every minute, 50 millions of tweets per day is a part. Retail access, consulting access, air transaction, constructions, food transport, steel, automobile, industrial, and then telecommunication is a part of a complete big data and IoT itself. You can see here which type of application, which type of conversation on the social media we are going to deal per day. You have multiple applications, multiple of access. You can see here we have interest, cultured access, comments and reputations, locations, video, documentation. I think you may also aware about that IoT application as nothing but your Zomato IoT applications by using Uber, Ola, Swiggy. These are the things where we can access. So what I can say, I can have a architecture, I have a cluster-based architecture, I have a different cloud-based architecture. That cluster-based architecture, cloud-based architecture, and the different architecture are combined with each other through different protocols, through different like we can say applications. So this is few examples. We are going to deal with examples. I'm just directly put it on a result. I don't want to like go in detail about these things, how to create a network, how to create the data node communication. This is a simulation. Then we are going to apply a particularly, we can say that that particular application by using different quality of services. For that purpose we require hardware, and that hardware we have a sensor, we have a processor, we have a transmitter. Then this is the prototype model. Then we have a receiver at the receiving end, we have a server, we have a server as in a cloud. So that is a hardware implementation. So what is node, what is data gathering, what is external data? That node is nothing but your autonomous device where we have a different sensors. Then data gathering by using a data capturing gateway to the external system. And then the external systems are storing that and managing that data on a cloud. So we have a sensors, we have a wireless communication, we have open source API. The different open source APIs are available. So we can design a hardware like this. There are multiple sensors. That multiple sensors can access multiple data. That flow of data. Then we have to design a hardware by using simulator. So these are the things which are most important. So this is, we can say, and that protocol format by using this particularly protocol format, how much data we have to access per second, per day, per minutes. So this is the way. So these are the way to access the data. We will not like go through in detail, but we'll just go through in the application of this particular data. So I can say the technology around us, the technology around us is agriculture, is most important factor. Today's topic is on agriculture. Today's topic, today's era is work on agriculture as well as energy, which is required to generate that particular access or the data or the system. Then we have a transportation system is a part of IoT. Then we have particularly medicine section is again a part of IoT. These are the applications, these are the technology. Then we have a education sector, again a part of IoT. We are going to deal with first agriculture. So which type of application, which type of, I can say that particularly applications we have. First is laser land leveling. What exactly it is laser land leveling, that we will discuss. Then crop disease detection is one of the application of including in the architecture. Then monitoring greenhouse condition is one of the application. Then irrigation and waste water management is one of the application in our agriculture. Then smart agriculture. So this is a part. We'll go through one by one. What exactly mean by laser land leveling? As we see here, we have a complete land, and we have to like plant a particularly trees or rope a particularly seeds. For that purpose, we have to maintain a land properly, so that through a particular, I can say that IoT application, we can design a hardware in such a way that it will maintain the level of a land. For that purpose, I need a less irrigation time. I will conclude that particularly part of less irrigation time. Improve food security because of the leveling of a land. Low energy, it required to seed, putting a seed in a particular land, that it required a low energy, again a low cost. That because of this particular hardware, we get a less greenhouse gas emission because of the different level of a land. Then improved income. As we see, we can plant a different seeds on particularly on a laser land properly. If the land is properly level in a level, then it can be a properly grow in a particular farming sector. So this is one of the application. Second application, I can say mobile based crop disease detection. You can see here, and we can observe so many diseases are there. As I know about that, we can say that cotton, for example. We can say that orange is one of the example. We can say that apple is one of the example. Different food, different agriculture material are going to develop through agriculture. So for that purpose, what I need to detect the crop. I need to protect that particular seed or a plant through a crop. So we have to detect the disease and then provide the proper feeding, or I can say that fertilizers, which is required to protect that particular disease, to protect that particular disease. So by using IoT, we have to do some sort of such devices which can get recognize an image, preventive measures if it is required for that particular plant to detect that disease. Even it will become a AI driven based detection. Artificial intelligence, machine learning based detection can be possible. We have to acquire a different diseases. We have to combine that particular data, and we can check with that particular photo. We'll get a photo through our mobile itself, and we'll compare the diseases. If that particular disease will get identified, then we will provide the particularly proper protection of that particular seed or a fruit or a particularly agricultural purpose. So this is a particular, we can say that AI driven disease detection. Even though we can also observe the regional weather, which type of seed we have to feed, we have to plant that which type of seed, we have to grow in which region or which weather. That can be also identified by using mobile based crop disease detection is a part. Again, the last point is nothing but your global and local disease libraries. We have to maintain on the basis of region, on the basis of weather, on the basis of global requirement and the local requirement. We have to gather the information of diseases, and on the basis of that, we can conclude that particularly we can say a disease, okay, where we have to identify which type of protection we require, which type of fertilizer we require, which type of particularly feeding of particular protection spray or other thing is required for that particularly disease. So we have a different database. We'll compare the database and we'll get the proper output. So this is one of the example of agriculture is nothing but your mobile based crop disease detection. Next example, I can say that monitoring greenhouse condition. As we see here a product, it will monitor the greenhouse condition, sensor in greenhouse, which will protect, which will identify the temperature, which will identify the humidity, which will identify the wind pressure, which will identify the soil nature, soil moisture condition. These are the different sensors we can like connect. We can just feed in that particular area, and on the basis of that, which type of water leveling is required for that seed or the plant, which type of temperature is required for that particular plant, which type of moisture conditions are required for that particular plant, that can be monitored by using a greenhouse condition. Preparing the materials as per the requirement of temperature, as per the change in temperature, as per the change in humidity, as per the change in wind pressure, as per the change in speed of wind pressure, as per the change in weather, rainy weather or cloudy weather. So these are the things is particularly we can protect that particular greenhouse condition. As I already mentioned about that soil and ambient temperature is a part of this particular greenhouse condition is we have a sensor based hardware which can monitor soil and ambient temperature, and we can protect that particular plant. Soil moisture also I also already mentioned, humidity I already mentioned, and that can be a completely solar radiation based device. As we see here, it doesn't require a battery. It will be a long life hardware which have a different sensors, and that sensors will provide all the data on a single click on a cloud, and on the basis of that database we can just protect our particular agriculture, complete agriculture. So this is one of the example, that is nothing that I can say that monitoring greenhouse condition. Am I if you have any doubt, any question, you can just ask, and you can just like put up your points itself. I'm very much happy if there is any another point or another concept we can add, and we can design a like particularly hardware. I have a 2 to 3 hardware a patent or the project for the my PhD student scholar, those who are doing on such patent, and that can be commercialized in a few days. These are the few examples I have, so you can also do such thing. Second example, as an agriculture purpose, irrigation and wastewater management. As we know that water is most important for health as well as agriculture purpose, so water quality assessment is most important through some sort of water leveling, water measuring quality, pH value, and other, even the gas sensor, okay, MQ2, these are the sensors we can use, and that by using that sensor, we can identify the quality of water, toxicity assessment of water by using this type of hardware. Only we have to insert that particular sensor in a water, and that information we will collect on a cloud through IoT. Nutrient content assessment are most important factor. Water level monitoring and control is again a factor. How much water we have to require to flow for, or we have to send it to the for the plant itself is one of the most important. Otherwise, some sort of seed or some sort of plant is will damage because of more water supplying to the particular plant. So this is again the point. And which type of water, sulfate water is required, some sort of somewhere we required a pure water, somewhere we required a rainy water, somewhere we required some sort of different condition of water. So these are the things which are most important factor for, I can say that irrigation and water management system. This is one of the application. as I see here, a future farm. We have a farming data on a single cloud at a server level. We can monitor by using drone itself. We can spray some sort of we can say that fertilizer or other thing through drone itself. We can monitor on animals itself. We can monitor tractor itself. Survey drones are there. Fit of agri-bots are there, which can identify. These agri-bots will identify or scan the disease or the bacterial infection on a plant. I can see here fit of agri-bots, which will identify the particularly the disease on a plant, and it will kill through we can say that laser beam. That also we did. This is one of my patent. We design a hardware in such a way that with that particular machine or a system is implemented in a tractor itself, or individually we have a robot. That robot will just watch the scan the plant level or plant complete plant, which particularly leaf have some sort of disease. That leaf will get either cut off through laser beam, or it can be completely crushed by using laser beam. So particularly I can say that a disease may not affect on another part of that particular plant. Is again a agri-board of application. We can observe on texting cows itself, and that all datas are available on your like we can say that cloud. So this is nothing but a future farm, and a small and smart future farm, where we have a climate smart, where we have a robotic smart, where we have a storage smart, where we have a production smart, where we have a processing smart, and where we have a sustainable smart, is a part of your agriculture. With respect to that, with time permits, Ankur sir, Ankur sir,
हाँ जी सर, हाँ जी सर, हाँ
can
जी.
I proceed with these particular examples?
हाँ बिल्कुल आप प्रोसीड करिए.
Yes, yes. With time permits, and if you have any doubt through audience, please audience can also share their views on this particular point. And few have few of the audience are respectable audience. I'm very very much thankful to them. So we can proceed with the energy.
रोहित जी चैट बॉक्स को ऑन कर दीजिए. जिसको कोई डाउट होगा तो वो चैट बॉक्स में लिख देगा. आप ऑन कर दीजिए.
Done, sir.
Okay. So we have a waste to energy. We have a smart meter. We have a Vristify. We have a hug jacket. We have a smart grid itself. So these are the different applications. What are those applications? As I have a particularly waste energy, we have a methanol material process. We have efficient combustion. We have fly ash capture, which is again a useful for, I can say that, agriculture purpose. We have a acid gas treatment. We have a bottom ash recycling, and that complete data is available on a cloud. I think someone have a doubt or question. Yeah. Name the app suggested for disease diagnosis. There are multiple apps. We can also design that particular app, sir. Dr. R.K. Singh. We can design our own app or a portal where we have to upload the data by using Kaggle, or we have to collect the data from some sort of agriculture system itself. As I mentioned, the example of I can say that uh, like we can say that we'll say about the any food or any. So we have to identify the initial stage of that food to the end stage of that particular food. So from that we have to gather all data, and then we'll get the particularly output. As one of the Ravi Singh sir is mentioned, how our modern technologies and sensors were used by the marginal and small or small farming. The precision and advanced farming is only for large farmers. No, sir, we can design a small devices which can be implement, or we can like use it for the farmer itself. We'll give it to them. This is again a CSR activity by so many companies. They are going to design some sort of such devices. For example, take Mahindra. CP Gurnani sir is a CEO of that particular Tech Mahindra. They are going to lead to design such type of devices, and it's a part of your sort of cyber security as well as a part of your agriculture and the energy sector is already done by CP Gurnani sir. Cost factor is, see, it's good. Again, Mohan Reddy sir is good question as a cost factor. See, there are multiple sensors, there are multiple processor, there are multiple applications. So we can design such type of devices as per the requirement of customer itself. For the small cost based customer, we can design such devices. Even as I mentioned about that, is there any available mobile app for disease diagnosis? Sir, yes, sir. So many apps are there available. We can go through the Kaggle, we can go through the some sort of open source API app where we have to search as per our requirement. Requirements in sodic soil for regulation of soil. See, sir, as per the soil requirement or the different types of sensors are available. MQ2 sensor is for particularly we can say that gas sensor, and some sort of different soil sensors which can be measured the different level of particularly wet and non-wet condition of that particular plant, or as well as the like we can say that land. So this is again possible. Thank you very much, Koteswar sir. Appreciate if you can suggest NPK sensor. Yeah, there are multiple sensor. Again, I can share you the all the details. Different sensors are there. If Ankur sir permits for tomorrow's session, so we can share the different sensors and different applications. That is a point we can do. As I can proceed with this particular, I can say that example of different application. Can we proceed with this particular slides? Hello.
प्लीज करिए सर, प्लीज जो डाउट्स हैं उनको भी रिजॉल्व करते रहिए और बाकी आप कंटिन्यू करिए सर.
Yeah, about the energy, we can see here we have different energy sectors, and for that energy sector are also important for the agriculture. We can see the particular complete setup, which is particularly we can say that power generation itself and sort of agriculture purpose itself. So waste power, waste bottom ash for the planting, land leveling, okay, metals. These are the things which can be possible, and that can be used by using energy itself. Smart meter we can use. So agricultural purpose, even the farmers can get all the details, accurate measurement and transmission of electricity, gas, water or heat consumptions data on a single app itself. Two-way information gateway, we can just on and off our applications or the devices, or we can get the information how much energy we have to consume for a month or for a day. Information of actual consumption of data can be also possible on a single click. Automated billing, invoice based or detailed metering data is also available. Demands side and management is also available by using smart meter. Will not waste much of time. Vristify is again example for the IoT, is one of the biggest example by using thermoelectric module. We can see here the thermoelectric module is get divided in two parts. One is the Pelter effect and one is the Seebeck effect. So by using that, Vristify is one of the technology. That same technology is implemented in a Hug jacket, where we have to if the winter season is there or the summer season is there, so we have to maintain the temperature of a body. For that purpose, we have to like design such a jacket which can maintain the inner temperature as well as the outer temperature of that particular jacket, and that can be again very much useful. Is nothing but your Hug jacket. This is nothing but a smart grid, where we have to integrate home, we have to integrate sites office, we have to integrate ecological vehicles, tractors and other things. We have to integrate wind generator systems, we have to integrate photovoltaic systems and solar cell and other renewable energy sources. We have to integrate hydraulic power generation, we have to integrate thermal power generation. nuclear power plant. This we can be integrate for the agriculture, where we have to require energy point of the things. Next example we have, next point we have a transport application of Internet of Things. The Internet of Things, automated car, autonomous car, stereo vision, passenger counter, lightweighted material malgift train. These are the examples. So we have a future car where we have all the details on a single car. As I put up the example of Alcazar. Alcazar is a Hyundai based company car, where we have a 32 cameras and 68 sensors, including that particularly car, can be operated through your mobile app itself. So this is nothing but an intelligent car and intelligent transport system itself. So these are the things which are get added in so particularly tractor or particularly car system itself. In the tractor itself, we can add these things. Means we can say that valet parking, we can say that driving mode, we can say that conference mode, we can say that ultrasonic sensor, we can add front camera, autonomous driving mode, we can add front camera, navigation mode, rear camera, the Wi-Fi, GPS, 2G, 5G systems we can add, and we can control everything through our cloud system or the mobile system itself. So these are the examples of automobile. A Malgave train is one of the examples, and we know very well about that, how it can work. We have medicine examples of IoT, Lumify portable ultrasound, digital pills, capsule endoscopy, robotic prothesis, then Internet of medical applications. So these are the particularly example of IoT, which is most important factor for the health itself, where we have to very much aware about that digital pill, that digital pill are very much useful. Provider portal, transmitting medical data after it is consumed, that particularly share the information we have, where we have a camera, where we have different sensors, and maintain the digital health. Then we have capsule endoscopy is one of the technology of IoT, where we have a lens, where we have a video chip, data antenna, system chip itself, and by using that we can identify the disease. We can identify that by using identification of disease, we can implement the particularly precaution, or the particularly we can say that medication to the on that particular disease itself. It is for we can say that health as well as the agriculture purpose. Then these are the nothing but your robotics information. We can say that we will implement by using IoT itself, and control by using IoT itself. AR and VR, augmented reality and virtual reality is the example of this particular artificial leg. So these are the things where we have a medical application. Temperature sensor, as I already mentioned, EMG sensor, ECG sensor, as I already mentioned, airflow sensor, GRS sensor. These are the different sensors which can observe the different data, different information, and that can be useful for agriculture as well as health monitoring system itself. So these are the things which are most important factor. I can say that is the most important point for the IoT itself. These are the few examples. I can say that digital paper system. I can say that 3D virtual tour, and we can also have some sort of slider. Means we have PCB or street paper. Then we have to draw a sensor node. Then through that particular sensor node, we can just connect the connectors or the wires. Okay. Then the silver and the water-based non-toxic link. Let's draw the concepts and get the output as per our requirement. So these are the things which is a part of IoT itself and can be possible by using IoT. So this is a few example of IoT. These are the most important factor of IoT. And as I already designed these things, these are my hardwares. These are my concepts where I can already design, and I have already sort of patent as well as copyright of this particular hardware as well. So you can search it my detail through YouTube itself. we can say that Dr. Rahul Pethe. You can search it out. This is nothing but an engineering in our daily life, and this is from my side. You can search it out myself through Dr. Rahul Pethe on a YouTube, on even though different LinkedIn. My page is available, my website is available, rahulmpete.com. So you'll get everything. So this is from my side. Thank you very much. And I'm extremely from my bottom of heart sorry for the technical issue and technical stuff. And thankful to Ankur sir, thankful to all the participants, those who patiently listen this particular detail. Of course, sir, we'll send it to sir itself. Our Ankur sir is a point of contact. So we'll send all the detail to Ankur sir. So from my side, thank you very much.
बहुत बहुत धन्यवाद सर, आपने इतनी ग्लिचेस से जूझते हुए भी आपने अपना प्रेजेंटेशन दिया, और इससे इसके साथ साथ मैं सभी पार्टिसिपेंट से भी ये कहना चाहूंगा कि आपने इतने धैर्य से सुना और इतनी ग्लिचेस के बाद आप बने रहे। बहुत बहुत धन्यवाद, आपने मेरा निवेदन स्वीकार किया, और साथ ही साथ सभी पार्टिसिपेंट्स का भी आभार कि इन परेशानियों और इन समस्याओं के बावजूद भी आप इन रहे, और अभी भी स्ट्रेंथ 219 है जहां 310 लोगों ने ज्वाइन किया था। सभी का तहे दिल से बहुत बहुत आभार। नए सेशन में नए आगाज के साथ नए स्पीकर के साथ हम बहुत जल्दी मिलेंगे। बहुत बहुत धन्यवाद।
थैंक यू वेरी मच।
सभी पार्टिसिपेंट्स लीव कर सकते हैं।